Hello engineers and welcome at our next video. This video will be about my testing. I did some modification on the bogies of our train and tried several testing. I already cleared the whole railway and now I can test anything I want. I kept the design of the bogies or the gears for the terrain, but I found several problems and I will show you this time. I did some small modification that you can see. I created it like it is much more designed to be better looking, and now we will see what's our result. I did or created this detaching wheels. Now these supporting wheels at the bottom, they are now connected to the main grid. Yeah, with this wire and merge blocks. Of course, I can disconnect them anytime I want, and they hold the train on the position. So let's go to the tests and we will see how will they behave. I have a mistake here. Now it's good. I tried something with the friction. Now our speed is quite small, so we are very slow. We can see the ride is okay, it's smooth, but still we are slow, so I will increase the speed to at least 60 meters per second. And now we can see the buggies are starting jumping. And the whole train too. And now we can see that the wheels can't hold all the mess that train now holds or contain, because as you can see I added 8 full cargos. These cargos are full of ore. Of course I could add another 4, but this is enough for my test, and it has a little bit problem with the higher speed and stronger centrifugal force. My side wheels are not so stabilized and they mess on the turns. It's like their strength stopped working and kept the train with the and allow train to hit the rail. And in this situation we can see it's not okay, because our main wheel on the left can't hold that. And that's not a okay result. That isn't okay. Of course I moved the main wheels to the sides, more to the sides, but I think I will redesign it and move them more to the middle a little bit, but it will not help anything. We can see what is bad now with it. On the ups and downs, these wheels are okay, quite okay, but the side wheels have extremely big problems on the turns So this is our result. Yeah, these wheels are not stable. They are not stable, and why is it? It's because of subgrids. Subgrids are not good at holding very strong forces. To be sure, you can see the cargos are all full. I used lots of thrusters to power it, so it will be faster. Yeah, so now the result is not good, so I did some modification. The first modification was to make gears solid, or bogies, to make them solid. So now in this model there are parts of the main grid and there are no rotors. I removed them and used merge blocks to attach all them to the body. So now all the wheels are on our main grid. And the result is okay, it's good, it's not bad. You can see that I will reach higher speed, like 80 meters per second. And bogies can't be stable because they are solid. But the wheels have less problems with the strength from the sides, so it's better. Yeah, we can see that from cabin. I thought the train without bogies will be a problem on this kind of railway, because there are quite big pieces, so it's not so smooth as my older rails. But we can see it's okay. The behavior is nice. I must be careful in this. Oh, I hit the brake, the hand brake. Yeah, that's maybe interesting information. All the wheels have a zero friction, but their braking system still work. It's a little bit funny. Parking brake work, and also my spacebar brake work, so it's nice, but you must keep turned on brake and allow parking brake. You need both of them, and the wheels will not brake the train to the 0 meters per second. Still you need some thrusters. This is a quite sharp turn. We can see the angles between the blocks are really big, so the ride isn't so smooth, but still I can clearly reach 40 meters per second without any problems. And of course our straight line up and down. I will reach maximal speed and we will see what it will do. The wheels are jumping, of course. They are always jumping. That's why you need more wheels. But you can see the train pass it very clearly. So it's really nice. The braking is a little bit strong. I removed the rail so I can't continue, but it's not a problem. I will fix it later for the next video. So our result for this solid gears, test result is positive. It's quite nice, but the small wheels, these 2x2 wheels, they have still a problem with the gaps between rails. So I did another modification. This type has still classic bogies, so the moving ones on the subgrids. So again, I lock the bottom wheels, they hold the position, and later I can show you what it will do if I will not use them. So I turn off the dampeners. I reach the higher speed, and we can see the same problem. Our centrifugal force is extremely strong and pushed our side wheels at the edge, and of course it creates a lot of force on our wheels on outer side, so they will starting bugging out of position, and that's all because of subgrids. And you can see the wheel is still out of position, and I'm moving very slow. That's not a correct behavior. For example, I can try to increase the strength to 70%, which is our maximum, as I said in the previous videos, and try it again. You can see how is it vibrating and jumping. It's a little bit better, but still you can see the damage to the side wheels and main wheels too. So the result with the bigger wheels, 3x3 wheels, still not good, and it's because of the subgrids. Now I can show you how it will look if I will move without these supporting wheels at the bottom. So now it's okay, it's still okay, but if I want to reach higher speeds, this speed isn't still big, but still the train will derail. So that's why I must use them. So the test result still not okay. So back to our fourth version with the bigger wheels and solid bogies. They are again part of the main grid, and again we will see how it behave on the same railway. You can see it has a more stability. I think I can a little bit increase the strength to 50 or 55%, because the train is now extremely heavy. We can see the gaps on the outer side wheels because the inner wheels are pushed to their limits, but still the train don't lose so much power. I don't use any power, and train loses very small speed. That's the advantage of the trains. You save lots of power. And you don't need so much power output. Now I will slow down because the turn is very sharp. it will naturally decrease the speed. As we can see, it decreased speed to 50 meters per second. I think for this sharp turn 40 will be safe, not 50. And again I will increase the speed. Now we already know it will be okay. I can show it from the cockpit how this traveling can look. First I thought the ride will not be so smooth. It will be a little bit cringy because there are I hit the brake. There are the solid gears and the distance between wheels are really big, so I thought it will have a problem with these rails, but the rails are quite big, so the gap between wheels isn't a problem. So test result, again, result of this test is simple. 3x3 wheels are still better than 2x2, little bit, and solid gears are the best. Yeah, they are the best for this behavior. If you have a lightweight train, then okay, you can use some subgrids, but in this case it's not good. Of course, I already made lots of trains with subgrids, as I can show you from previous videos. For example, Blue Dragonfly had subgrids. If I place it, then these bogies are on the rotors, and they behaved quite okay because of one different thing. Yeah, realistic trains, they are similar. Yeah, I have bogies on the rotors, but on the rotor there are all the wheels, all the types of the wheels. But on this design I used every part of this gear was a subgrid, or is a subgrid in this case. So for one car I had 8 subgrids. Yeah, 2 for each side, for each direction, or front and rear part. Together it's 8, and that's why it behaves so badly. So maybe for a later design I will use 3x3 wheels. I will use solid gears, but also I will decrease the distance for the side wheels. For the main wheels it's okay, but for the side wheels it can be not a big problem, but still it can be a small problem. I will move the train again back to the sharp turn, and we will see why is it there a problem. I will try to describe it. Now the wheels, the side wheels, are in one line, and the turns are around. They are like how to say, circle, and you are trying to touch the circle with the line, and there is only one position where the wheels will be in the correct position, for example. So in this case we can see the train is in touch with our outer wheels on the right side, yeah, because we are going this way, but now I'm backing, so I will move here and go forward. So now our front and rear wheel on the inner side are touching the rail, but the middle wheels are not touching the rail. But on the other side, on the outer side, the inner wheels are touching, but outer wheels not, and that can be a problem. These inner wheels on the outer side of the turn creates stronger force on our wheels on this side, because there is no tolerance, there is no gap. And for this situation I need to all wheels on the inner side to touch the rail. So that's why this is bad, and I must decrease the distance between wheels. So I will move this wheel more to this side and this wheel more to this side. They will be closer to each other, and then it will behave a little bit better. This rule is mainly applicable for sharp turns, but of course it happen with the all turns, but on the different scale. So that's the next modification. Another modification is I will try to lower the body of the train a little bit down, by one block maybe. I'm not sure how I will hide the wheels. I must create some holes in the body, but I think it will be okay. The bottom wheels, I will don't need to change them. The system works okay. They are stable and they only help a little bit, so I can keep them small. But I can say it looks okay. It looks quite realistic a little bit, and still it can hold lots of cargoes. Of course, I prepared the last version, and it's this one. What's the difference? The difference is these wheels have friction, and I will show you how it can affect. There are no thrusters, so all the power comes from the wheels. I can control them with the timer blocks, where I increase or decrease their propulsion overdrive. So now the overdrive is at the maximum. I can say the side wheels now have zero power, zero friction, because I had a problem with the placing, yeah, and now we can see a problem with the friction. Maybe you can't understand it correctly, but I described it in my first video, I think. These wheels are trying to go only forward in a straight line. But the side wheels are forcing them to turn. But the friction between wheels and other grids are always stronger than on the voxel part. So it makes a really big problem. The force is so strong that it broke the side wheels, and our main wheels are out of the rail. Yeah, that's the problem with the friction, and you can't solve that. Yeah, you can use boogies on the subgrid, but it will help on a little bit. Still, you have a problem. You can say for the turns, I can add friction to the side wheels. Of course, I can, but there will be a small problem, maybe bigger. The same problem is here too. If there will be up or down, I would like to show it later, but it's not possible because the train will not reach so far. Maybe I can try to decrease the friction from 40 to maybe under 20%. It should be no better. Here you can see it's much more better. But I'm not sure how it will work with the power. I can try it, but I really not sure if it work. Hey, it work, but the power transfer is not strong. But yeah, it work. There are some simple rules about friction between wheels and grids, where if you go under 20%, then the friction is enough to move, but it's also enough to transfer some power. If you go under 10%, then the power output is not transferred. And if you go more than 30%, then the friction is almost strong as 100%. So maybe I find best setting. I can transfer power and also move. The maximal speed is now limited to 200 kilometers. I can a little bit increase it, maybe to 300. Last time I said, and now we can see vibrating wheels and the problems with them. They try to increase their speed and they can't. So this speed is not safe. I must decrease it again to back to the 200, and it should be a little bit better. I can help it now with the thrusters. Oh, that's much thrusters. I need just 2 of them. Yeah, but the friction is still very strong. I can check there is maximal propulsion overdrive, and the train is still can't move clearly. I can try to decrease the friction under 15%. It's now better, but the train can't accelerate. The acceleration is very slow. I can try to keep it. But I think for the survival worlds this can be still okay. I will now release our supporting wheels and I will increase the friction of our side wheels and we will see how it will behave. Maybe. Yes, now we can see. You see that flying? That's because of the friction. The friction tries to move the train. Yeah? Another good example. The friction is so strong the train can't move. But of course I used very strong friction. It's a little bit funny. I can try to decrease it to under 15%. And we will see how it will behave. I miss some thrusters. I will increase a little bit the speed. And maybe the percentage under the 15 will be the best solution for this, because the friction isn't so big, so it can still move, and the friction is also enough strong. Oh, so not enough, but still it's enough to move properly. The last time I used now some thruster power to increase that, but now I don't use any thruster power and everything is on the wheels now. And we can see it's working. The strength on the main wheels, on the ups, was bigger, but it wasn't so big, so it worked. Yeah, so now you have the best setting for the wheels if you want to use them as a source of your power. But I recommend to use 3x3 wheels. They should be more stronger in the power output. Maybe the mode will tell us something. Is there some power output? Max torque. Yes, there is max torque and kilowatt output. So the 5x5 has 300 kilowatts and max torque is almost 5 kilonewtons per meter. If we use 1x1 wheels, the power is third. Yeah, 150. So it's not double, but still it's bigger. 3x3, it's 25, or of course 30% more than the 2x2. And the torque, we can see the torque is almost the twice. From 1 kilonewton to 2 kilonewtons. And of course 5x5, 2.5 times more torque and 50% more power output. So it's clear, yeah, we can see the power output is bigger, and that's why you should use 3x3 wheels. They are still small, they are more powerful, and they behave a little bit better than 2x2 wheels. I don't recommend to use 1x1 wheels for anything like this. Of course, there are some train systems which use 1x1 wheels, of course, but they are not a good source of power, and then they don't have so strong suspension, for example. They are not so good for gaps. So I think for this video, I think it's all. It was just about the test result, and later you will see a complete, maybe complete train or some prepared design, and we will focus our minds to control unit. The control unit is a brain of the train which use thrusters as a source of the power. Maybe I have some blueprint with it. It's like this one. I have lots of versions. This control unit, maybe I will show it later. So that's all, and see you later. Bye.